Hi, and welcome to the video on translations of functions. A translation is a sliding movement, either vertically or horizontally. This is the function y equals x squared, a parabola. I can translate this parabola horizontally, or I can translate it vertically. If I want to translate it diagonally, I'll need some kind of combination of horizontal and vertical movement. Well, functions that are written as y equals f of x can be translated horizontally by adding or subtracting a constant to the x variable, such as y equals f of x plus b. Now if b is positive, then the graph will shift to the left. If b is negative, then the graph is shifted to the right. Let's take a look at an example. Here is y equals x squared. If I add a value to x before it gets squared, such as y equals x plus 2 all squared, then the graph is shifted to the left. If I subtract a value from x, let's say y equals x minus 2 all squared, then the graph is shifted to the right. Notice that the parabola doesn't change in size. The only thing that changes is the translation left and right. That's what happens when you add a constant to the x before it gets squared in this situation. Now functions that are written as y equals f of x can be translated vertically by adding or subtracting a constant c to the actual function itself, such as y equals f of x plus c. If c is positive, then the graph will move up, and if c is negative, the graph will shift down. Let's take a look at what that means. Again, we'll start with y equals x squared. If I add 2 to y equals x squared, then the graph will shift 2 units vertically. If I subtract 2 from x squared, then the graph will shift 2 units down. To move a function diagonally, a combination of adding to the x variable and adding to the function is necessary, as in the function y equals f of x plus b plus c. So for example, here's y equals x squared. If I use a combination, such as y equals x plus 2 all squared plus 2, then the x plus 2 all squared will shift it 2 units to the left, and the plus 2 on the end will shift it vertically up. Let's try the example from the text. Here we're asked to sketch y equals x minus 2 all squared, take away 5. We begin by noting that y equals x squared is a parabola with a vertex at 0, 0. This means for our function y equals x minus 2 all squared take away 5, that vertex will be vertically and horizontally shifted or translated. Because we have x minus 2 all squared, the graph will be shifted to the right 2 units. And because we have a minus 5 on the end, it'll be shifted down 5 units. So our new vertex will be at 2 minus 5. We now should work out the x-intercepts by allowing y equal to 0. Why don't you pause the video and see if you can't work out what the two x-intercepts are going to be. Here we go. By letting y equal 0, we can solve this by adding 5 to both sides and getting 5 equals x minus 2 all squared. Then we can take the square root of both sides, giving us plus or minus root 5 equals x minus 2. We add 2 to both sides, giving us 2 plus root 5 and 2 minus root 5 as values for x. We could find those values on a calculator and then use those as our x-intercepts of minus 0.20 and 4.20. Next up, we should work out our y-intercepts by allowing x equal to 0. Again, pause the video and try and work out what the y-intercept is going to be. Here we go. By letting x equal 0, we get y equals 0 minus 2 all squared, take away 5. That gives us y equals 4 minus 5, which is minus 1, giving us a y-intercept of 0 minus 1. Let's take this to our graphing program and see what it looks like as we create it. Here we go. We begin by plotting our vertex at 2 minus 5. Next up, we plot both of our x coordinates of 2 plus root 50 and 2 minus root 50. The final coordinate that we worked out was our y-intercept of 0 minus 1. Now, you might be happy to sketch through that, or you could possibly draw up a table of values like this one, and then plot the points that are there and draw your graph through those points, like this. Be careful to go through your vertex at the bottom and then come through to the top. You can see that our graph has been translated from a normal y equals x squared, which would be here, translated horizontally 2 units, and then translated vertically down 5 units. Good luck with your translations of functions.